Good morning. Today we're going to see about the force couple system. We have seen about the concepts of moment. Moment is nothing but force into perpendicular distance. Here we are going to see about the force couple system and followed by an application oriented problem in the force couple system. Let's get into the topic. Force couple system. Here, this particular image, we are able to see two forces are acting which is parallel to each other and in opposite directions. This particular image will cause a turning effect. This is what the couple does. In a couple, moment about any point is same. In the other words, sum of moment of two forces about any point is same. If you want to find a moment by considering this as a point A, this as point B, and the distance is A, small a. The moment about point A is, it is in the clockwise direction. So M suffix A is equal to FA in clockwise direction. Similarly, moment about B, MB is equal to F to reach B, it is in clockwise direction, and F into A. So the moment about point A and point B will be of similar in both the cases. This is what couple may be defined as. And here, this we are using it for some applications to replace a force, a single equivalent force. If it acts on an object, we want to replace that a single force to another point without changing an effect. So that we'll introduce the two forces in the another point in opposite directions. So the resultant force will be of same. Let's see with an image. See here, a force P is acting in upward direction in point A. I want to replace the force P to B with a couple. So I'm introducing a force P in point B, opposite directions, in upward direction and downward directions. Now there is no change of resultant force in both the images. So now I'm considering these two forces and I'm changing this as a couple here in clockwise direction P into A. This is how we are replacing a force to another point without changing the effort. The force at point A is replaced at point B with the force and couple. Let's see a simple problem. A parallel force system which is of four forces acting is shown here. We want to make it to a single equivalent force and a force and a couple at point A and point B. This is what we have to do. Here, we are able to observe that only vertical forces are here. There is no horizontal forces. So we can take horizontal forces as sigma of h as 0. To find the vertical forces, it is equivalent to the resultant forces. 30 Newton acts in the upward direction, 115 downward, 70 in upward, and 110 in downward directions. So the sum of resultant force is minus 60 Newton. That is 60 Newton in the downward directions. So now we have to identify the position of the resultant. Yeah, to find the position of the resultant force, we have to use the formula of Huygens theorem. F1 d1 plus F2 d2 plus F3 d3 is equal to R into d. This formula need to be used and we have to identify the position of the resultant force. F1 d1, that is the point is starting point. So it will be starting the origin, it will be of 0. Now for the 150 Newton, it rotates in the clockwise direction. So we are using minus sign 150 into 1. The sum of distance for the force 70 Newton is 2 meters. So it is in the anti-clockwise direction, 70 into 2. Then for the last force, F4, 10. It is have to be rotated in the clockwise direction to reach point A. So 10 into the distance for point A, perpendicular distance for point A is of 3.5. So now the cumulative, that is a summation of moment about a point A is 45 kilonewton meter in the clockwise directions. To find the distance, perpendicular distance, we have to use the formula sigma MA is equal to R into D or R into X. We'll get the X value as 0.75 meter. Now I'm just drawing the image for the answers which I have. Now I have to replace the force to point A with the couple. So I'm introducing the 60 Newton force to the point A in both the sides, upward direction and downward directions. Now I'm replacing it with the moment, that is coupled. So 60 into 0.75, it is 40 Newton meter. It's 40 Newton meter. Now I have to replace the force and couple at point B. Similarly, I have identified and I have to complete the problem. Thank you.